Hello everyone, welcome back to the channel. I hope you all are fine. So we will see today's daily challenge on Leetcode and we will try to solve it together. So let's see the problem statement first. There are n one index robots, each having a position on a line and a health and a movement direction. You are given a zero index integer arrays, positions, health, and a string directions. Direction I is either left, L for left, and R for right. Okay, so you will be given three arrays. Okay, the first array will show that the where is the position of the current ith robot. Health will show what is the current health of the ith robot, and directions will tell that in which direction the robot is moving. It is either left or right. All robots starts moving on the line simultaneously at the same speed in their given directions. If two robots ever share the same position while they move, they will collide. Okay. Uh, if two robots collide, the robot with the lower health is removed from the line. Okay, and the health of the other robot decreases by one. Okay, so please make sure that you pay attention to the things which is told here. uh, the the robot in case of collision, the robot with the higher health survives, lower health immediately reduced to zero, and the higher health also decreases by just 1 unit. The surviving robots continue in the same direction as it was going. If both the robots have the same health, they both are removed from the line. Okay, and your task is to determine the health of the robots that survive the collision in the same order the robots were given. So, if let's say you see that initially your health array is was something like 5, 8, uh, 2, 12, 7, 6. After some processing and everything, you realize that after all the collisions and all, your, let's say, somehow I'm not telling this will be the answer for this array, but let's say your answer was something like this. uh, okay, let's say your answer came up to be something like this. Then what will you do? You will return your answer as something like this, 4 to 11. So only the surviving robots you will pick up and you will return their health. Okay, so I'm talking of the health array in this case. Okay, you have to return the final health array in the same order it was given to you in the input. Okay, so yeah, I hope that at least the problem statement is very much clear to you. So again, I am explaining in a number line type kind of thing. You can assume that there will be some robots, okay, in some positions, and some will be moving left, some will be moving right. Okay, and as a result, some will collide with some. Okay, so let's say this has a health of 10, this has a health of 10, this has a health of 6, this has a health of 5. Okay, so you see, this will go to left as it is going. These two will collide with each other. Okay, since 6 has a lower health, this health will reduce to 0. After the collision, what will happen? This will be still moving towards 10 left. This will be moving to the right with 9, and this will be not moving at all. It will be not present, it will be removed from the line, and its health will be reduced to 0, and this will move to the right. Okay, since the things which are moving to the right also have the same speed, these two never collide with each other, so no further collisions happen, and your final array will be returned as 10, 9, 5. Okay. Okay. Now, if your initial array was input something like this, 5, 6, 10, 10, then you have to return the array as 5, 6, not 6, 5, 9, 10, something like this. Instead of 10, 9, 5, then you will return. It matters that your initial input was what it is given to you. Okay. In the same order, you need to return it. Okay. So I hope you will first try this problem on your own and then only continue watching the video. Yeah. So let us just start. So there is a very similar problem also, and it is a medium problem. It is asteroid collision. You can search this on Leetcode and try to first solve that because it is very similar. And if you know the ideas, some of the ideas of it, yeah. Otherwise, also you can just continue watching the video. No problem with that. Yeah, we will discuss in detail. Now, one thing is very clear that, see, if you take a pair of robots and see the conditions for collisions, okay? So now we will try to write some observations, okay? First observation is that when the two robots will collide, let's say we have this pair left and left. So two robots are going towards left and towards left. No matter what is their health, no matter what is their position, they will never collide with each other. So collision can never happen in this case. Let's say both are moving towards right. Again, very similarly, collisions cannot happen in this case. Uh, let's say one is moving towards left and another moving towards right. So if it is moving towards this left and if it is moving towards this right, again, you see, they cannot collide, never collide with each other, right? The only case of collision you can see is R and L. If it is moving towards right and another is moving towards left, then only the single case is there for collision. Only this particular case you need to handle, because in these cases only the collisions will take place. Okay, so uh, you need to, let's say, keep this right index. Whichever robot you see is moving towards right, that has the potential to collide with someone in future that will move towards left. So not only right and left, the left should come after the right, okay? Because you see, if left comes before the right, they will not collide, okay? So R and L should be there in order. So left should come after the right. So if you get a right, it means that it can collide with some future robots which is moving towards the left. If you uh, get a left, it means that it can collide with some past robots which have been moving towards the right. Okay, so what you do when you get an R, you store it into the stack. So let's say you have a robot at position 2 which is going towards the right. Okay, so as you see, first of all, you if you notice something, the positions may be even given you jumbled. Okay, 3 5 2 6, see, they are not in the correct order. They are not in the order of 2 3 5 6, which happens in a number line. So at first, definitely you are going to sort it, because as you see, by intuition only you can understand, from if we are iterating from left to right in a number line, okay, and then we are analyzing each and every robot and analyzing the collisions of that, then definitely the positions must be sorted. Okay, positions must be sorted. So that we will do it separately. No problem for that. Okay. So positions must be sorted. So after you sort the positions, use as we were discussing, let's say we have a robot which is moving towards right. Okay. So we will store that index into a stack. Again, let's say if we have another robot which is moving towards at position 4, which is again moving towards right. Again, we will store that robot into the stack. Let's say then in some future position at 7, there comes a robot which is moving towards the left. Then we will start taking out elements from the stack. Okay, we will see that, hey, my top element of the stack is now 4. Okay, its position is 4. So we'll go and check the health. So let's say this robot has a health of 6. This robot had a health of, let's say, 3, and this robot, let's say, had a health of 7. Okay, this 7 index robot has a health of 7. So as it moves towards left, we see that at position 4 there is a robot with a smaller health, 3. So it will reduce to 0. That particular health will reduce to 0, and my current health will move from 7 to 6. Now I have a health of 6. Also, I find another robot in the stack which is moving towards the right at earlier index, and it has a health of 6. Since now I am having the same health as the colliding robot, both of the robot's health will reset to 0. So what I will do in the initial health array, I will just go to those particular indices and make them 0. Whichever index has the smaller health, or if the both healths are equal, I will just go to those positions and make it 0. So I will modify the original health array. The original health array. If it is required, I will make the health to 0. If it is required, I will decrease the health of, let's say, a particular position by minus minus. Okay, as it is reducing by 1. So if a larger value collides with a smaller value, the larger value reduces by 1, right? So I will do this, or let's say I can also do something like this based on whichever is greater or smaller. And in this process, my health array will be keep on modifying. Okay, my health array will be keeping on modifying. So let's see the coding. The coding is not at all difficult. So let's have this positions dot size. Okay. Uh, Also, let us first sort these positions. Okay. And since we need the particular indices for that positions, I will keep a vector of pairs. This is nothing but a vector of pairs. Yeah, whatever be the case. What I'm trying to insert into this is nothing but, since I am trying to sort by positions, so pos dot pushback, I will do positions of I and I. Okay, so this is the pair. This is the pair. So this is a pair of elements which I will try to push. And if you know that if I just sort it, okay, so if I just sort it, pause dot begin, pause dot end, I will get, what will I get? I will get all these positions sorted. So it by default sort by the first value. Okay, if you don't know, this sorts by the first value. So my first value will be sorted, and also I will get the corresponding index to that sorted value. With this index, I am able to extract my health, I am able to extract my direction and everything. So yeah, that is it. That is it. And we also need a stack of integer where we will keep the positions. Initially, the stack will be completely empty. So after this, again, I will start iterating. Okay, uh, through all the values, but I need to iterate in this position indices only. So this I will try to extract now. So this I is nothing but index, which will be positions of I1. Okay, I hope you do understand. I go to the ith value of this position and extract one means the second element. I extract the second element, which is nothing but this index. So I am having my current index. This is nothing but my current index. Okay. Okay. So what I will also do now, if again, now coming to our algorithm which we framed, if we have an R, it can collide with some future L. So we will push that R into the stack. So if in case by any chance we get and R. So directions of index, if directions of index by any chance happens to be R, what I will simply do is stack dot push this particular index. I will just simply stack dot push this particular index. Else, else my directions is left. Now, if my directions is left, it can collide with some past R. Okay. So if the stack is not empty, I will just keep iterating through the top values of the stack, as I had told you. Okay. As I got a large value here, as I got a large value of 7, moving left, okay, I try to see in the stack which are the values which are moving towards the right. So stack stores only those values which are moving towards right. So, and I keep on seeing that, hey, if this is smaller than me, remove it and reduce by my health from 7 to 6. Again, I will see the next element and so on. Okay, I will keep seeing elements. So while stack is has some value, while it is not empty, and my current health should also be positive. If my current health is only reducing, okay, so my current health is also greater than 0, then I can see my elements from the stack and see what happens to them. So this is an index from the stack, so I just take this stack dot top, stack dot pop. Okay, I also remove this value from the stack. Now I see that what will happen if my health of index, current health, is greater than the health which is picked up from the stack. Okay, the last one, the last health. Okay, I can also take mark this as a last index. Okay, last index so far. What if the my current health is greater? What will happen? You already know, right? My current health will reduce by 1, and the health of this last value, I will just reduce to 0. So as I told, I'm modifying the original health array. And else if I have something different, okay, something different than this, what will that be? That will be essentially something like this, and things will just get the reverse, okay. So yeah, and just copy these two lines over here and just to the reverse. Initialize this to 0 and reduce this by minus minus. But now you notice one thing is that your current index, your current robot was moving towards left and it got destroyed. Okay, and it got destroyed, also reducing the last robot health. Also, it reduced the last robot health. But initially, we had already picked up the last robot and deleted it from the stack. But still, it is still alive. My last robot, after fighting with my current robot, is still alive. I need to push that element into the stack. So stack dot push last. Since it still survives, I need to push it back. Else you see both of this health, you can just simply make it 0. Okay, because both of the healths are 0 now and no need to push anything into the stack. So yeah, that will be all. If you see, that will be all. My final health array is ready now. Now I can see my final vector answer. If you remember, I had told you that if your initial health array becomes something like this, okay, you need to return 4 to 11. Okay, so you need to get rid of the values which are 0. So you keep only the ones which are greater than 0. So to iterate through these values, and you check if health of I is coming to be greater than 0, then you push back this answer, health of I. Okay, if it is greater than 0, then only you put it back to health of I and you return your answer. That will be all. That will be all. If you try to run it and check if we did some mistake or we need some debugging or not, you see it gives you an accepted. If you try to submit it, let's see if it works for all the test cases. So you see, it did work for all the test cases, but the runtime and memory is not so good. To improve the runtime and memory, I will tell you a method which you will try it out on your own. You should definitely try it. Okay. So you, instead of sorting it in this way, sorting it in the vector, instead of creating a vector of vector and sorting it in this way, you only need the sorted value of the second element. You see, I sorted those values and only use the second element. Okay. So you can use a comparator function for that. So first you can try using instead of vector of vector, you can try using vector and pair of integer comma integer. Okay, after and if some memory complexity or this runtime complexity improves, you can then try to use a comparator function. Okay, to sort only these indices. Use a comparator function to sort only the indices. As you can see in what method they have done in the editorial, if you see, uh, they have used a comparator function as I was expecting, because you see they have used a function. Okay, they have sorted this indices using the comparator function and not by the default value. This is actually easier to do, the method which I showed you. This is much easier to do, but yeah, it gives you a less runtime complexity, and only that I think will make the difference. So you see it, you try to go ahead and use the comparator function and then tell me whether your accuracy improved or not. So yeah, that is all. That is all for this video. I hope you did understand. There was nothing complicated in this. If you still have any doubt, you are free to ask me in the comment section. I will meet you in the next video. Till then, thanks a lot.